The points of intersection of the two parabolas y is equal to ax square and x is equal to ay square is obtained by substituting the value of y from the first parabola into the equation of the second parabola. Therefore, the points of intersection are obtained from the equation x is equal to a times ax square whole square. In other words, x is equal to a cube times x raised to the power 4. Moving all terms to the left hand side and taking x common, we get x times 1 minus a cube times x cube is equal to 0, which implies that x is equal to 0 or x is equal to 1 upon a. When x is equal to 0, the value of y is obtained from the equation y is equal to ax square and is equal to 0. And similarly, when x is equal to 1 upon a, the value of y is equal to 1 upon a. Therefore, the points of intersection of the two parabolas are 0, 0 and 1 upon a, 1 upon a. Now we plot these two parabolas on the Cartesian plane. The parabola y is equal to ax square is symmetric about the y-axis and y is always positive. The parabola x is equal to ay square is symmetric about the x-axis and x is always positive. The area enclosed between the two parabolas is as shown, and its value is obtained by taking a small strip whose height is equal to the difference between the ordinates of the two curves multiplied by the thickness of this strip, which is dx, and then integrating between the points of intersections of the two curves. Therefore, the required area is equal to the integral of y2 minus y1, where y2 and y1 are the ordinates of the two curves, multiplied by dx, and their limits of integration are x is equal to 0 and x is equal to 1 upon a. And since the area is a positive number, we take the modulus. Now the ordinate of x is equal to ay square is obtained by solving for y, which is equal to square root of x divided by square root of a. And the ordinate of y is equal to ax square is ax square. Therefore, the required area is equal to the modulus integral 0 to 1 upon a square root of x divided by square root of a minus ax square dx. This is equal to the modulus of 2 upon 3 square root a multiplied by x raised to the power 3 upon 2 minus a upon 3 x cube, limits being x is equal to 0 and x is equal to 1 upon a. Putting in the limits, this is equal to 2 upon 3 square root a multiplied by 1 upon a square root a minus a upon 3 times 1 upon a whole cube. This is equal to 2 upon 3a square minus 1 upon 3a square, which simplifies to 1 upon 3a square. Now this is given to be equal to 1 square units, and therefore solving for a, we get a is equal to 1 upon square root 3. The other solution, a is equal to minus 1 upon root 3, is rejected because we are given that a is positive. This is the required answer.